partly my topic. Instead of only speaking about the Russian subject and going back to a period which is much older than the time of the Gelfand seminar, of which Sava has just told us, I will consider problems of ideology and mathematics with some examples connecting themselves. And the first part will be the topic of the Russian creation of the Moscow School of Mathematics. So we will see from the time of the birth of the Moscow School of Mathematics in the beginning of the 20th century that some characters have been promulgating themselves to the time Slava was just telling us, and then I will give some parallel examples connecting with them. There seems to be an agreement among historians of mathematics to consider mathematical science as a cultural phenomenon submitted to cultural influences. This general agreement may be superficial. One would like to understand better how locally this influence proceeds and to estimate its epistemological implications. We restrict discussion here to some example of ideological factors, philosophical, religious and theological, political, having to do with set theory and occurring essentially from 1890 to 1945 in Europe. So I apologize for those of you who have studied our articles and books with Lauren Brand. I will give a quick survey of our book with Lauren Brand, Naming Infinity, a true story of religious mysticism and mathematical creativity. In this book we have studied a very special case where religious factors stimulated the development of mathematics. Then I will present some other circumstances where ideological motivation played some role, and I will conclude by trying to search for some condition for an external strong influence on mathematics. So in a few words about the Russian case of naming infinity. So we studied the birth of the Moscow School of Mathematics at the beginning of the 20th century with patrons Luzin, Yegorov, so they were born respectively 1883 and 1870. Both were under the influence of a religious Orthodox mystical sect, the name worshippers, in Russian, and one of the members of this sect was their friend Pavel Florensky. This sect, reinterpreting mystical practices going back to the Byzantine period, followed the sayings of the Orthodox Russian monk Ilarion, who developed theological principles based on the identification of God with its name. We have discovered by a careful analysis of circumstances and personal archives of Luzin fighting with unsolved problems of set theory that the theological thesis of the Ineslavia acted in resonance with the issues of foundation on mathematics. Truly, after the first period of the introduction of set theory by Jean-Michel Kantor, problems had arisen, paradoxes leading to a crisis, usually written with a K, in mathematics, concerning the infinities and leading to foundational problems related to the existence of new mathematical objects having no explicit description. Of course, the discussion is about the terms existence and description. But among them, the higher infinities of Kantor was an issue. The large majority of French mathematicians was reluctant or even opposed to the new object, if some had more hesitation. For example, Borel, Baer, Lebesgue. Let us quote Lebesgue, for example. He wrote, "Can we convince ourselves of the existence of a mathematical object without defining it? To define always means naming a characteristic or property of what is being defined." I insist on the word naming. And Jacques Hadamard, who was the most open-minded among French mathematicians, still for him, referring to the question of the definition of what a function is, wrote around the 1905 period, the question of what is a correspondence function that can be described is a matter of psychology and relates to a property of the mind outside the domain of mathematics. And I insist on the words psychology and the word mind. On the contrary, under the guidance of Losing, the head of the future Moscow School of Mathematics for a period of 20 years, stimulated by the strong analogy they saw between their theological thesis and the mathematical construction, where the various infinities were known only by their names, sort of, the young Russian mathematicians around Losing went further in the mathematics and even created, independently of Hausdorff in Germany, the descriptive theory of Sept, whose aim was to give names to all subsets of the continuum and by this way answer the famous continuum hypothesis. The two different cultural contexts led to contrasting results. French Cartesianism led to skepticism and hesitation, whereas Russian creativity and enthusiasm was stimulated by a religious background. Another cultural influence one should point here is that, for example, the axiom of choice of Zermelo and discussions of naming had reintroduced the active role of the individual in the mathematical creative process, as the one who chooses in Zermelo's case, the choice, you choose, or the one who has intuition, who defines, who gives names to mathematical objects. How to be sure of mathematics born from such subjective elements? This debate, introduced by Frege, was a part of the general discussion on the role of subjectivity of the subject, of the I, me, as opposed to objectivity, a debate common then to many fields of science and culture. The scientific self was giving a fundamental role to intuition, and I refer to Poincaré's distinction between various intuition, and I also refer to the discussion, very broad, general, thorough discussion in the book of Lauren Daston and Peter Gallison, Objectivity. And I just want to remark here, because it's a complicated topic, that from the theological point of view, mystical intuition plays an important role in the theology of Miroslavian in the way the names carry some meaning. This intuition which gives strength, they call it energy, to the name, for example, in one of their theoreticians, Bulgakov. Is there a Russian specificity? This is a topic I was mentioning, and I want to go back to this. The circumstances we have just outlined were exceptional. Change of paradigm in mathematics with a new set theory, Kantor's paradise as referred by Hilbert. Exceptional mathematical leaders in France, Poincaré and Borel, as in Russia, Losing, and we have seen another situation later with exceptional leaders. But still, the specificity of Russian mathematics persisted and could even still be perceived after the end of the Soviet regime, and the best Russian mathematicians were disseminated in the top centers of research in the world, as we have seen with Slav. So this robustness suggests some deep cultural roots. I don't want to prove anything, because I know that in these kind of topics we cannot prove anything, but I just suggest. And here are the points I want to suggest. First, the strong belief in the unity of knowledge and culture in general, a form of universal holism. For the Russian intelligentsia, all domains of culture are strongly interconnected. And an example among many others is the work of Pavel Florensky, sometimes called the Russian Leonardo. He worked in mathematics, geology, aesthetics, philosophy, while being a priest, theologian of Yugoslavia, a friend of Losing and Yegorov. For example, during his theological work, he studied the religious icons, and considering that they were using an inverse perspective, that led him to study mathematical non-Euclidean geometry. Close connection between domains of culture, including science and religion, have always been favored by Russian intellectuals. Whereas in France, the first translation of Kantor's Sept theory censored their non-mathematical content, in Russia the work appeared first in a journal called Philosophical Mathematical Journal. This kind of universal holism, opposed to, for example, the French Cartesian attitude, was given recently a theoretical status with the concept of semiosphere proposed by the well-known Russian philosopher of culture, Yuri Lotman. Inside the mathematical field itself, this tradition had consequences. It implied there has never been any strong distinction between pure and applied mathematics. A unifying role was given to mathematics in all sciences and further, and I just give an example. Nikolai Bugayev, he was born in 1837 and died in 1903, the father of the famous symbolist poet Andrei Bieli, and who was the professor of Yegorov, gave a universal role to the discontinuous function when they appeared in mathematical studies around 1880, and it decided that they were representing free will, so made a connection between mathematics and philosophy, to say religiously. For mathematics, this tradition goes back to Lomonosov, considered as the father of Russian science, and his teacher and advisor for mathematics, the German philosopher Wolff, who was a strict adept of Leibniz. The same humanistic inspiration for science appeared under some German romantic influence, Schelling, with the Ljubomudri, who have been recently studied by Dmitry Bayin. For sure, this Russian form of holism contributed to the linking of religious and mathematical ideas in use in school. There's a second point which I will not insist, it's the freedom that could be used by a Russian mathematician more freely in mathematics than in physics or chemistry, as you can imagine, and this freedom in the mathematical field was, compared to other domains, was prolongated except at the time of, for example, the Luzin affair in the end of the 30s, where Luzin was attacked and repressed. And finally, our experience, so to go back for a minute to Slava's talk, our experience of the seminars at Moscow University at the end of the 60s, complemented by various testimonies as have been quoted, showed the importance of the leaders of the school and heads of seminars. I remember very well that I was struck going from seminars in Moscow to seminars in Paris by the cultural difference. There was some difference that I was younger, but I could feel it. The origin of this role of guru, the term of guru, has been used by Russian mathematicians. Luzin earlier, later Gelfand, Arnold, Shafarevich, is not clear. It might come from a mixture of old non-European tradition, but also from the religious role of the Pope, or also maybe of the rabbinic schools. There were a lot, as Slava said, of Jewish students and professors at some point attending. In any case, we could feel a real difference with the West European or Anglo-Saxon ways to practice mathematics, but I'm open to discussion. So I want to make some parallelism with some older or more recent situations in Germany and in French. The first one is the Gordon-Hilbert quarrel of 1890. So I refer to an article by Colin McClarty, who has made a detailed study of the mathematics of the Gordon-Hilbert debate. I don't know how to say Gordon in German. Gordon, sorry. Which presents an analogy with the later discussion on mathematical existence. In 1887-1890, some years before the birth of the crisis in Sept theory, David Hilbert gave a non-constructive proof of the existence of a finite basis of invariant for forms. This is technicalities are not important here. He used, just know that he used some kind of transfinite arguments involving an infinite series, and this created some polemics with his colleague Gordon, an expert in the field. Whereas Minkowski, cherished pupil of Hilbert, announced that this type of conceptual proof was the sign of the modern age of mathematics, Gordon declared after reading the first version of Hilbert's proof, this is not mathematics, this is theology. Hilbert's interpretation of this strong refusal was to declare that Gordon had not understood his method, in fact quite new and astonishing at the time. For Gordon, Hilbert had proved the existence of a mathematical object without giving any hint on a possible construction for it in a similar way as one is asked by theologians to believe in God without any knowledge about Him. Remember that this is a little bit earlier to the discussion I had about French and Russian, second period of the introduction of theory of Sept. It is interesting to note, comparing with the later Russian context, that Gordon had been using in his long-lasting work on the same topics some computation with symbolic, quote, symbolic terms that he called Faltung. I've looked for the different acception of the term, which at some point could not be given any meaning or even be extracted in the middle of computation. So they were just symbols. These symbols play also a role in Hausdorff philosophical texts, which are partly published and will be published. Hausdorff has a discussion of formalism and other philosophical attitudes of mathematicians, so I can give references to Hausdorff discussion. And I have found, discussing with the redactors of the editors of Hausdorff collected works, I remind you that Hausdorff was also very active at the beginning of general topology and descriptive theory of sets, that this role of symbol has been a strong constant in the German philosophy of mathematics through Hilbert and further. Another example I want to give, which connects with previous ones, is the role of Bourbaki in modern mathematics. The influence of Hilbert and his program of axiomatization on the birth of the Bourbaki group are well known. Some ideological factors could also be taken into account. They influenced even the style and strategy of the collective. It has been noticed that the group had for a long period a big proportion of Jews and Protestants, and among them Claude Chevalet, who was quite operational, let's say, religious Protestant and strict advocate of algebraic purity. I can give anecdotes, I don't know if I have time, of the behavior of Chevalet in terms of purity. This may have influenced, for example, the absence of any graphic representation in the book and the refusal of any pictorial. In fact, some years before, the discovery in Göttingen of the axiomatic method was a true revelation for the young French mathematician from École Normale. Not only was it a way to bypass sterile discussion on the existence of object, you just had to write the axiom needed, assuming the existence of the objects satisfying them, but the new method was promising. Its universality would allow to treat various questions in one shot. Tools of the axiomatic method were explicitly associated in the only general philosophical text we have, which is signed by Bourbaki. It's the Le Lyonnais, Les Grands Carrefours, Les Grands Courants de la Pensée Mathématique, which was published at the end of the war. Tools of the axiomatic method were explicitly associated with Taylorism in the economical and industrial field. I quote translation of Bourbaki. In fact, I think it was Dieudonné, but I'm not sure. The axiomatic method is nothing but a Taylor system for mathematics. Hilbert was even given by Minkowski the surname of General Director of Mathematics. In the same reference, however, Bourbaki confessed that the mathematician worked, quote, by direct divination, another way of accepting the importance of intuition. This is how I interpret direct divination. The analogy with working methods of the industrial era remained for a long time compatible with the ultra-democratic methods of Bourbaki's collective work. You know probably that no text was accepted before everybody would say, would agree with it, with the text. So they had various, big number of versions of their manuscript. And this collective work, democratic method, was partly inspired, I think, by Chevalet, who was very left politically engaged. Okay, some partial proposal for temporary conclusion. What are the conditions for ideology to influence strongly mathematical creation? Even if there are no mechanical rules that would imply direct important liaison, even if the same cultural phenomenon can have opposite consequences. One can try to analyze the way this influence occurred in the period we consider, two periods we consider. We have given essentially examples corresponding to the two different periods of the last century, beginning and after 1935, the rise of modern mathematics. In fact, a radical turn occurred around 1935, which saw the victory of the rising force represented by Alexandre, Hilbert, and later Bourbaki on the declining current of Borel, Brouwer, and losing the victory of the new paradigm of axiomatization structure on the earlier intuition and Brouwer's intuitionism, meaning mathematical objects. In ideological terms, this was also the period of the triumphant fight in Russia of Marxism-Leninism over religion. I just mentioned, quickly referring to our book of Graham, that there was a fight against Yegorov, who was accused of being religious, mystical, and there was a dramatic trial, Luzin's affair, where Luzin was attacked by most of his previous pupils, among them Pavel Alexandrov. It is the same year, 1935, that occurred the first meeting of the Bourbaki group, the first International Congress of Topology in Moscow, where Andervey was invited by its organizer, his friend Pavel Alexandrov. The letters from Weyer to Alexandrov, from Alexandrov to Hausdorff, show a striking confluence of personal friendship, political agreement in support of the regime in Russia against Luzin, and mathematical confidence in the brilliant future of mathematics. The violent critic of Alexandrov against Luzin pessimism, when Luzin dared in 1925 to suppose that some mathematical problems might never have any solution. See what happened with the later results in logic. Echoes the ideological claims of the brilliant future of communism. Dugac felt even obliged to give a softer French version of his study on the Luzin affair because he didn't want to publish the violent attacks of Weil against Luzin. So I consider this kind of parallelism of the years 1935 to suggest that there is something behind that, and that the external influence on mathematics can be strengthened by maybe the presence of some strong universal themes, or maybe themata even, like here, the objectivity and subjectivity discussion. At some other period, it could also be the thema of order against chaos. These simultaneous events of the mid-30s, the different components we just listed, present complex hidden connection, and maybe a better understanding of these resonances will tell us something on the nature of mathematics. Thank you.